Hello viewers, welcome to my channel. I'm Hasham. Now I'm going to start the problems on linear programming. So after so many videos on theory regarding different types of programming problems, particularly about linear programming, because most widely used, frequently used programming problem is linear programming. So I have explained the meaning, definition, advantages, limitation, everything in the previous videos. So if you have not watched the earlier videos, I suggest you go to the playlist of my channel, select the subject Operation Research, select the videos of linear programming, be perfect about the concept, then you can understand the problems. Now, before starting the problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Always keep ready the problem. Without problems, you cannot cannot understand anything about the lecture. Take the screenshot of the solution of the first 5 questions, then I'll explain every point in detail. Now see here, the problems of linear programming consist of first formulation problem. Then we have the solving the linear programming problem by graphical method. And in the next unit, we solve the problems by simplex method. So before starting the solution of the problem, a student must know how to formulate the problem, how to put the problem in a mathematical model. That is the first step of learning in linear programming problems. And directly in examination, sometimes it will ask you only to formulate the problem, not solving either by graphical or by simplex method. Simply it will ask you to formulate the problem. So in this video, 5 problems I have selected only on formulation. That means the problem should be put in a mathematical model. Now first question you see, XYZ chemical company is producing 2 products A and B. So decision variables, we have to find out how many units of A and how many units of B to be produced. The processing times are 3 hours and 4 hours per unit for A on operation 1 and 2 respectively. That means 2 operations are there. 2 resources are there. So every product must pass through first operation and then second operation. Some time is required on first operation and some time is required on second operation. And 4 hours and 5 hours per unit for B on operation 1 and 2 respectively. So A product, how many hours on operation 1 and 2. For B product, how many hours on operation 1 and 2 are given. The available time is 18 hours and 21 hours for operation 1 and 2 respectively. This is the constraint. We don't have more than 18 hours on operation 1 and we don't have more than 21 hours on operation 2. So this is the limiting factor. We don't have more than this time. So we can make use either this time or less than this. For example, operation 1 18 hours. We can use either 18 hours or less, but we can't use more than 18 hours. Similarly for operation 2, 21 hours is the maximum time. We can make use 21 hours or less. Then the product A can be sold at 3 rupees profit and B product at 8 rupees profit per unit. Formulate the problem as a linear programming problem. This is the first problem on formulation of LPP, linear programming problem. First of all, how many decision variables are there? 2. A product and B product. In order to make A product and B product, we are having 2 resources. That is operation 1, operation 2. Now, it will be easier to formulate the problem if we put the data in this table. In this table, first of all, I have taken resources. The resources are operation 1 and operation 2. And here decision variables are A and B. And this is the maximum availability of resources. So resources are operation 1, maximum availability is 18 hours. For operation 2, maximum time is 21 hours and the profit per unit of making A product is 3 rupees per unit and for B it is 8 rupees per unit. The profit is given, maximum time is given. Now how much time is required for A product on operation 1 and operation 2. It is given in the first line. The processing times are 3 hours and 4 hours per unit for A. This is A. 3 hours and 4 hours. This is 3 hours and this is 4 hours. This 3 hours on operation 1, 4 hours on operation 2. This much time is required to make 1 unit of A product. Similarly, and 1 and 2 respectively, and 4 hours and 5 hours per unit for B on operation 1 and 2 respectively. So 4 hours on operation 1 and 5 hours on operation 2. This is 4 hours and this is 5 hours for product B to make 1 unit. That's all. Now we have put all the complete data in this table. What we have to find out, how many units of A product and how many units of B product we have to manufacture. So let X1 is equal to number of units of product A to be produced to maximize the profit, and X2 is the number of units of product B to be produced to maximize the profit. So X1 and X2 are the unknown values we have to find out. X1 number of units of A, X2 number of units of B, that we have to find out. Now objective function. When profit is given, our objective is to maximize the profit. So objective function will write maximize profit Z is equal to, per unit how much profit we are getting? 3 rupees. How many units of A we are making? X1 units. So 3 into X1, 3X1 plus, what is the per unit for B product? 8 rupees. How many units of B product we are making? X2. So 8 into X2, 8X2. So 3X1 plus 8X2. This is the maximum profit we can get, right? Subject to constraints. The constraints are, we have limited time in operation 1 and limited time in operation 2. Now, how much time is required per unit of A for operation 1? 3 hours. Same operation 1, how much time is required for B product? 4 hours. So per unit 3 hours on A, per unit 4 hours on B for operation 1, and maximum time available is 18 hours. So how many units of A we are making? X1. So 3X1 plus 4X2 should be less than or equal to 18. So here you can see, subject to constraint, 3X1 plus 4X2 less than or equal to 18. The first constraint. The second constraint is operation 2. Maximum time available 21 hours. Per unit of A requires 4 hours. Per unit of B requires 5 hours. So 4X1, X1 number of units of A, and 5X2, X2 number of units of B. So 4X1 plus 5X2 less than or equal to 21. 4X1 plus 5X2 less than or equal to 21. Only 2 constraints because we have 2 resources, right? And non-negativity restriction says the values of X1 and X2 should be 0 or positive. It will never be negative because we cannot produce negative units. We can produce either 0 unit or positive. The value of X1 and X2 will never be less than 0. It will always be 0 or more than 0. So that's why non-negativity restriction, X1 greater than or equal to 0, X2 greater than or equal to 0. This is called the formulation of LPP. So in LPP model, we have 3 parts. The first part is objective function. We want to maximize the profit. And second one is a set of constraints, inequalities. So here we have 2 operations, 2 resources, so 2 inequalities. Lastly, non-negativity restriction. That's it. This is called the formulation. After formulating the problem, we need to solve it either by graphical method or by simplex. Now, second problem I am going to read out. ABC Furniture Firm manufactures tables and chairs. So our decision is regarding how many tables and how many chairs to be produced. Data given below shows the resources consumed and unit profit in manufacturing a table and a chair. So we are given the unit profit and we are given the resources required to make one table and one chair. Here it is assumed that wood and labor are only two resources which are consumed in manufacturing furniture. Just like previous problem, operation 1, operation 2. But here we have two resources, wood and labor. Wood and labor are the only two resources. And the manager of the firm wishes to determine how many tables and chairs should be made to maximize the profit. Our objective is to maximize the profit. So how many chairs and how many tables should be manufactured? Formulate the problem as linear programming problem. It is not asking you to solve. It is asking you to formulate the problem. The only formulation part we are going to do. Exactly similar resources are wood in square feet and labor in hours. Profit, unit profit in rupees. The unit requirement, table, chair and amount available. Amount available represents maximum availability. We don't have more than 300 square feet of wood. We don't have more than 110 hours of labor time. So labor time can be used either 110 or less. Wood can be used either 300 or less. But we don't have more than this. And how much is required? 30 square feet to make one table and 20 square feet to make one chair. Right? Similarly, labor hours are 45 hours to make one table and 10 hours to make one chair. Total work. And 6 rupees is the unit profit, per unit profit for table and 8 rupees per unit profit on chair. So exactly table is given in the problem. Resources, wood, labor. And decision variable are table and chairs. Maximum amount available is 300 square feet of wood and 110 hours of labor time. Profit is 6 rupees per unit of table and 8 rupees per unit of chair. Right? 30 square feet is required to make one table and 20 square feet of wood is required to make one chair and maximum wood available 300. 45 hours are required to make one table and 10 hours required to make one chair and maximum time available is 110. That's it. First of all, we suppose let x1 be the number of tables to be prepared, to be produced to get maximum profit. x2 is the number of chairs to be produced to get maximum profit. The unknown variables are x1 and x2, number of tables and number of chairs. Now formulation of LPP. Our objective is to maximize the profit. What is per unit profit here? 6 rupees. By making one table, 6 rupees is the profit. And how many tables we are making? x1 tables. So 6 into x1, 6x1. How much profit per chair? 8 rupees. How many chairs? x2. So 8x2. So 6x1 plus 8x2, this is the maximum profit. Subject to constraints. Now wood. 30 square feet per table, 20 square feet per chair, maximum is 300. So we can write 30x1 plus 20x2 less than or equal to 300. 30x1 plus 20x2 less than or equal to 300. Now 45 hours per unit of table, 10 hours per unit of chair and total maximum hours 110. So 45x1 plus 10x2 is less than or equal to 110. Because we don't have more than 110 hours, we can make use either 110 or less. Similarly 300 or less. So that's why this symbol is less than or equal to. And non-negativity restriction says x1 and x2 may be 0 or more than 0, but it will never be less than 0. We cannot make negative number of tables and negative number of chairs. It will always be positive. That's all. This is the formulation of LPP second problem. Now third problem. A manufacturer can produce two different products A and B during a given period of time. Each of these products require four different manufacturing operations: grinding, turning, assembling and testing. The four resources are there. So every product A and B will pass through 4 stages. The manufacturing requirement in hours per unit of product are given below. How much time is required for grinding, turning, assembling and testing given. for A product, B product. Grinding time 1 hour for product A and 2 hours for product B. Turning 3 hours for making 1 unit of A and 1 hour for B. Assembling 6 hours for A and 3 hours for B. Testing 5 hours per unit of A and 4 hours per unit of B. This is the time requirement per unit of A and B on all the 4 operations. The available capacity of these operations in hours for the given time period are grinding 30 hours, turning 60 hours, assembly 200 hours and testing 200 hours. This is the maximum time available for all the 4 processes. We don't have more than this time. That means our inequality will be less than or equal to. We can make use either less or equal. The contribution to profit is rupees 2 for each unit of A and 3 rupees for each unit of B. The profit per unit is given. The firm can sell all it produces at the prevailing market price. Formulate the problem as a linear programming problem model to maximize profit. Exactly similar problem. See here, formulation of LPP. Resources are grinding, turning, assembling, testing. That's what given. Maximum time available is 30 hours on grinding, 60 hours turning, 200 hours assembling, 200 hours testing. Not more than this. And the profit per unit of A product is 2 rupees and 3 rupees is profit per unit of B. And how much time is required per unit of A is given. For 1 unit of A, 1 hour on grinding, 3 hours on turning, 6 hours on assembly, 5 hours on testing, that is given. Similarly, to make 1 unit of B product, how much time is required in grinding? 2 hours, turning 1 hour, assembly 3 hours, testing 4 hours. Table completed. Now let x1 be the number of units of A and x2 is the number of units of B to be produced to maximize the profit. Right? Now objective function. Our objective is to maximize the profit. Per unit profit 2. How many units we are making? X1. So 2x1 plus 3x2. That is the objective function. This is the maximum profit. Now subject to constraints. The first constraint is grinding. The maximum time available of grinding is 30 hours. So here 1 into x1 is x1. x1 plus 2x2 is less than or equal to 30. So x1 plus 2x2 is less than or equal to 30. First constraint completed. Second, 3x1 plus x2 is less than or equal to 60. 3x1 plus x2 less than or equal to 60. Third, 6x1 plus 3x2 is less than or equal to 200. Here you can see 6x1 plus 3x2 less than or equal to 200. Right? Last one, 5x1 plus 4x2 less than or equal to 200. 5x1 plus 4x2 less than or equal to 200. Non-negativity restriction, x1 and x2 will be 0 or positive, it will never be negative. That's it. This is the formulation of LPP, third problem. Now see the fourth one. A company manufactures 2 products A and B. Product A yields a contribution of 30 rupees per unit and B product contributes 40 rupees. Again we have 2 products A and B. Profit per unit 30 and 40. It is estimated that sales of product A for the coming month will not exceed 20. There is a constraint, restriction that A product cannot be sold more than 30 units. More than 30 units. And sale of product B have not yet been estimated, but the company does have a contract to supply at least 10 units to a regular customer. Product B we have not estimated. We don't know how much is the sale of product B, but it's sure that one customer is there to whom compulsorily we have to supply 10 units. That means compulsorily we have to make a B product 10 units, or it may be more, but it will not be less, because compulsorily 10 units we are going to sell to a customer for product B. A product maximum sales is 20 units. We cannot sell more than 20. So there is a restriction on sale of product A and B. Now, machine hours available for the coming month are 100. There is a restriction. Machine time availability is 100 hours only, not more than 100. And product A and B take 4 hours and 2 hours respectively. So A product take 4 hours per unit and B product take 2 hours per unit. Maximum time available 100. Labor hours available are 180. So maximum time available for labor is 180. And the product A and B takes 4 hours and 6 hours respectively. Per unit of A 4 hours, per unit of B 6 hours. Maximum labor time available 180. And material available are restricted to 40 units of the two products. Each use 1 unit of material per unit. The 1 unit of material is required to make 1 unit of A and 1 unit of material is required to make 1 unit of B. And the maximum material available is 40 units. So we have machine time restriction, labor time restriction, material available restricted. Apart from that, sale is also restricted. Now formulate this problem as a linear programming problem. That's it. Now see carefully here. Formulation of LPP. Let x1 is equal to number of units of product A to be produced to maximize the profit, and x2 number of units of product B to be produced to maximize the profit. Right? Now formulation of LPP, objective function. Our objective is to maximize the profit. How much profit per unit of A? 30 rupees and 40 rupees. 30 rupees for A and 40 rupees for B. That's the profit per unit. How many units? X1 and X2. So 30 X1 plus 40 X2 is the objective function. Maximizing the profit. Now, subject to constraint. Regarding machine time, the machine hours available are 100 and each unit takes for A and B 4 hours and 2 hours respectively. So 4 hours time is required to make 1 unit of A and 2 hours required to make 1 unit of B. The profit per unit of A is 30 rupees and the profit per unit of B is 40 rupees. So how many units of A we are making? X1, and number of units of B product is X2. So 30 X1 plus 40 X2, that is the objective function. Now subject to constraints. The machine time available is 100 hours, whereas each unit of A and B take 4 hours and 2 hours. So 4x1 plus 2x2 is less than or equal to 100. So 4x1 plus 2x2 less than equal to 100. First restriction completed. Second is labor hours available is 180 hours and the products A and B take 4 hours and 6 hours of labor respectively. So 4 hours per unit of A, 6 hours per unit of B. So 4x1 plus 6x2 less than or equal to 80. Last one, material is restricted up to 40 units and each unit of A and B takes 1 unit of material. That means x1 plus x2 less than or equal to 40. These three restrictions completed. Now sales, there is a restriction on sales. So for A product, you can see it is estimated that sale of A for the coming month will not exceed 20. That means we cannot sell more than 20 units for A product. The A product is x1. Number of units of A is x1. So x1 will be less than or equal to 20. x1 less than or equal to 20. Similarly x2. That means number of units of product B. Here it is given B, sale of product B have not been estimated, but the company does have a contract to supply at least 10 units to a regular customer. The sales are not estimated, but it's sure that we have to supply 10 units compulsorily to a customer. That means our sales will be 10 or more, but not less than 10. So X2 will be greater than or equal to 10 units. These are the 5 restrictions available. Non-negativity restriction says X1 and X2 must be greater than or equal to 0. We cannot produce negative units. That's it. Now, one last problem, problem number 5. A company manufactures 2 products P1 and P2. Each product uses lathe and milling machine. The resources are lathe machine and milling machine. And the decision variables are P1 and P2. The processing time per unit of P1 on the lathe is 5 hours and on the milling machine is 4 hours. The processing time per unit of P2 on the lathe is 10 hours and on the milling machine is 4 hours. The maximum number of hours available per week on the lathe and milling machine are 60 hours and 40 hours respectively. We don't have more than 60 hours on lathe machine and we don't have more than 40 hours on milling machine. And the profit per unit on selling P1 and P2 are 6 rupees per unit for P1 and 8 rupees per unit of P2. Formulate linear programming model to maximize the profit. Here only two resources are there, lathe machine and milling machine, right? So here formulation of LPP, X1, number of units to be produced of product P1 to maximize the profit. Similarly, X2, number of units of P2 to be produced to maximize the profit. Objective function. What is the profit per unit? It is 6 rupees and 8 rupees. So 6x1 plus 8x2. This is the objective. Now restriction. Maximum availability of lathe machine time is 60 hours. This 60. And the maximum milling machine time available is 40 hours. Maximum time, that's why we can make use either less than or equal to. We don't have more than 60 hours, we don't have more than 40 hours. We can make use either 60 or less or either 40 or less. Now how much time is required on lathe machine for P1 product? 5 hours. For P2 it is 10 hours. Lathe machine 5 hours per unit of P1. So on lathe machine 5 hours per unit of P1 and 10 hours per unit of P2. So here we can put the restriction 5x1 plus 10x2. 5 number of hours to make 1 unit of P1 and 10 number of hours on lathe machine to make 1 unit of P2. So 5x1 plus 10x2 less than or equal to 60. Similarly for milling machine 4 hours per unit of P1 and 4 hours per unit of P2. So 4x1 plus 4x2 less than equal to 40. And non-negativity restriction says x1 and x2 must be greater than or equal to 0. That's all. So totally 5 problems I have selected to get a complete understanding about how to formulate the problem as LPP. See, if in examination this type of questions comes, first thing is you must know how to formulate. Then only you can be able to solve either by graphical method or by simplex method. The first step in learning LPP is how to formulate the problem. If you do not understand this, how to formulate the problem, you cannot be able to solve it. That's why watch this video twice, thrice, then only you can be able to get the command on how to formulate the problem as a LPP. So 5 problems I have completed. Inshallah, in the next video we'll start solving the problem by graphical method. So if you're satisfied, give a like to the video, share my channel, give your views, give your messages and subscribe if you have not yet subscribed. Inshallah, we'll continue our doing the problems in the next video.